Hello and welcome to this session of Introduction to Autonomous Systems. In this session, we will trace the evolution of the artificial intelligence as a discipline along with various milestones that were achieved during this period. So, let us begin today's lecture. Initiation of AI as a discipline is generally believed to have started in around 1943 by McCulloch and Pitts, and is also believed to have originated from three basic sources, that is physiology, neurons, propositional logic and Turing theory. This also gave rise to the concept of artificial neurons, which were simple devices working as just on-off switches, where its on condition depended on sufficient stimulus from nearby neurons. It was also shown that any computable function could be computed using a simple network of neurons, including logical connectives. If we look at the initial developments, this particular start by McCulloch and Pitts was followed by the neuron updating rule of Hebb in 1949 and also the development of a neural network computer which was called SNARC by Minsky and Edmonds in 1950. These initial developments laid foundation for what was to come in subsequent years and decades, and it was also the same phase where Turing came up with his test of humanly thinking and initiated dialogues for machine learning, genetic algorithms and reinforcement learning. So, all these ideas started around this time, that is close to 75 years ago. Of course, all these were informal activities and developments, and only in 1956 the formal initiation of AI happened, with McCarthy and others organizing a workshop on such subjects as automata theory, neural networks, intelligence, and the agenda which they proposed for this workshop was as follows. It said, among other things, every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. This was the premise or the hypothesis with which they started this workshop, and it was mentioned that in this workshop an attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans and improve themselves. So, essentially you will realize that this kind of said everything about what artificial intelligence was ultimately to be as the various developments took place. Of course, also at the same workshop, Newell and Simon presented a computer program which they called Logic Theorist, and the whole idea of this program was to think non-numerically and solve a mind-body problem. This was also the phase that is around this workshop where the AI developed as a separate discipline from cybernetics, operations research or even mathematics, which were already fairly well developed, and there were a lot of research and lot of results which were available from these domains. The implication of this development of AI as a separate discipline was essentially to kind of counter the structured rigor of mathematics, operational research or cybernetics, and the intention was to focus more on human faculties, for example, creativity, self-improvement, languages, and making machines for such tasks. Of course, once this initial push was given, the next 2 decades proved to be significant in terms of the amount of work which was done to show that computers could go beyond manipulating numbers and become instead a general problem solver. Until then, everybody felt that computers could only manipulate numbers. So, it was a significant milestone in the development of artificial intelligence that the computers now were looked upon as general problem solver machines. And around this time, there were many other similar programs which people developed, such as geometry theory prover, checkers player, and also this phase saw the evolution of Lisp as a tool for programming AI type of tasks, which was a specific separate language which was developed for this particular application. But all of these finally hit the roadblock in the form of limited computational resources, for the simple reason that in order to solve the kind of problems which people were thinking of and the magnitude of the problem that people were dealing with, the computational resources simply were not a match for the kind of problems that were required to be solved. However, people still continue to develop the discipline of AI on a parallel track, while the computers themselves were evolving and developing at a reasonably quick rate. They brought in the idea of micro world along with vision, constraint propagation, learning theory, natural language processing and its understanding, and planning to AI. So, all these things such as vision, constraint propagation, learning theory, natural languages and planning, they all were included as important elements of the AI discipline as a whole. In fact, an example of this thought process was the blocks world, which was developed, which involved arranging blocks of various sizes and colors in a particular way using a robotic hand. This is a schematic of a typical blocks world task that was given to an AI driven artificial hand, and blocks of different sizes were identified based on their shapes, size and color, and then they were arranged as per a specified strategy. This perhaps became the first level at which an AI kind of application could be demonstrated effectively. And there were a lot of hope and optimism in this initial phase of about 2 decades. And AI also had a success in solving problems with human like strategies. And so people started expecting probably too many things, and they far exceeded the ground realities in terms of the delivery time frames. And the another issue which came up, apart from the limited computational resources which were in any case hampering the development, that when the language processing was brought in, initially there were literal interpretations of sentences without worrying about the subject matter, and in the process the systems which were being evolved either resulted in wrong solutions or no solution scenarios. And of course, another issue was scalability of complex problems. that the moment you started increasing the size of the problem, the complexity of finding a solution, they started multiplying manyfold, and very quickly people realized that the fact that a program can find a solution in principle, which means a solution exists and it can be found, it does not mean that it will so happen in practice. Simple reason that the problem would be intractable. Of course, this belief was primarily based on the fact that you had more than adequate computational power. That was never the case, and more importantly, the combinatorial explosion of search space was so much that almost all the problems became intractable. There is a third handicap which also affected the progress of AI during this phase, which was primarily related to the kind of model of a neuron which was being used just as an on-off or two-position device, what was typically called at that time the perceptron model, and it had highly limited learning capacity. So, if we were to conclude this phase, which was the initial churning phase of AI, we could say that AI as a discipline evolved from a simple neuron model and gave ideas about neural network computers, inputs from Turing test, and essentially established the basic benchmarks for any AI system. This was definitely done during this phase. So, at this point we will close this segment and we will continue this discussion in our next session. So, bye and see you in the next session.